Hello everyone, I am İsmail Mertkan, and co-authors are Tuğçe Tezel and Volkan Kovan. Today I'm going to present you Functional Anatomical Models Production by Additive Manufacturing. Additive manufacturing is a reasonably new generation production method that depends on adding thin layers to produce desired models on top of each other. Models that are desired to be produced with various design programs can be efficiently designed on digital media thanks to various design programs. The use of a digital platform for layout allows the planned models to be shared and developed. Unlike subtractive manufacturing, the absence of sawdust at the end of the AM process ensures that essential production resources such as material, energy, and time brought about by chip formation are not wasted. Depending on the type and the working principle of AM, different materials can be utilized to emerge as a result of research like metals, plastics, and composites. This easy-to-use technology was initially used mainly in the prototype production. Developments and research advanced the AM technology to manufacture original or replacement parts for the rising industry. AM can also generate parts with complicated geometry that the SM might or would never produce. All these superiorities over the other production methods ensure that AM technology is used in many areas, and the area of disposal is increasing day by day. One of the many areas where this rapid, inexpensive, and approachable manufacturing technology is used in the field of medicine. In addition to producing anatomical models with the ability to produce complicated geometries, this method is also used to produce products that can change people's lives, such as medical instruments and devices, personalized prostheses, and dental prostheses. Purpose of this study. In this study, the applications of AM technology in medicine are examined, and the studies using AM technology in the production of functional anatomical models used in preoperative planning or education of students are reviewed. Anatomy. Anatomy is a science that studies the body's shape, structures, organs, and relationships with each other. There are many sub-branches of anatomy, and these branches have been increased with the studies. Today, new methods are still being discovered by research. Anatomy is also a detailed course that is vital for medical students. Anatomical models are used as educational materials for students to increase the quality of education. Functional anatomy is a sub-branch of anatomy and is the main subject of this study. The use of additive manufacturing in functional anatomy has a wide range of fields such as educational material, artificial organs, prosthesis, bone production, medical tool, medicine kit, and dental health. Application of additive manufacturing in medical field. There are many examples where AM technology is used in medicine as well as in many fields. Researchers have shown that the use of AM technique in medicine has a large share, and the studies have increased year by year compared to the previous one. In the medical field, there is a need for customized products that cannot be mass-produced. In such cases, AM provides low-cost manufacturing with the ability to produce complex geometries quickly. The growing range of AM uses a broader range of materials available every day. Thus, continuous improvements lead to and offer higher and better part quality and increased usage areas. Biomaterial studies intended to produce similar to real organs can be cited as an example of material advancement for AM. Medical models produced by articulated manufacturing are of vital importance as educational material, especially for medical students' education. In addition to these use, These models are also used for diagnosis and treatment. An example of this is the creation of a model based on data obtained by screening tumors. By looking at these models, the spread of a tumor can be examined, and necessary precautions can be taken. By looking at these models, surgical plans of fracture cases can be made, and property risks can be evaluated. Studies have shown that models used as educational materials can be produced at a low cost. AM can fulfill such demands in designing prostheses with complex structures that traditional methods cannot produce. A hearing aid can be shown as one of the essential products for patients' health and comfort. Organ production with additive manufacturing means that patients who need organs do not have to wait for a new one. Studies have been done to produce artificial heart valves, artificial ears, ear cartilages, and liver organs. A study was conducted to create a liver using 3D printed polymers for similar tissue with the real liver. Unlike AM, bones and furrows are hollow structures that are difficult to produce using conventional methods. In a study, similar bone tissue intended to be used in skull implants was tried to be obtained by combining some chemicals. The study's next goal is to use real cell and bone material that may be possible using AM technology biomaterials. More specific solutions can be offered to patients by producing three-dimensional dental models with the oral scanning method. Mandibular models can also be produced to measure surgical instruments and screws using the fused deposition modeling method. Today, drugs are produced in mass production to appeal to the masses. It is planned to produce with AM technology with the right amount of chemical mixture in tablets. In this way, unique and more effective drugs can be produced for patients. The approval of 3D fabricated drugs by the FDA has increased the number of studies in this area. Medical devices may need to have complex forms in some cases, depending on surgical techniques, and AM technology can meet this requirement. Literature review. Young et al. Investigated whether 3D models are useful in informing patients and planning surgery. For this, many patients were divided into two groups with ankle fractures. Traditional methods were used in treatment of the first group, and specially produced 3D models obtained by scanning the patient's ankle fractures were used in the treatment of the second group. Doctors created an operation plan with printed models, informing patients about how the surgery should be performed and their conditions. After surgeries, doctors and patients conducted surveys with questions about whether the model is useful for treatment and communication. A model is sufficient to show fracture details according to the survey results, and patients have been informed thanks to the model gently. According to the surgical records, the operation time and blood loss were less in the second group, which used a 3D model compared to the first group. Zhang et al. Randomly divided many patients with heel fractures into two groups to compare them with conventional therapy and 3D model assisted therapy. Special surgical plans were made with models produced according to the data obtained by scanning the fractures of the patients. The results of the treatment of the 3D model supported group was better when evaluated in terms of operation time and blood loss. In the literature, various studies have produced models with AM method in the treatment of patients with knee joint fractures. It is aimed to reveal the effectiveness of preoperative surgical planning, patients' information, determination of necessary applications, less operation time and blood loss, and low-cost prototyping studies of patient-specific fracture models. Smith and Jones selected a neck and throat models and used the fused deposition modeling method to print. One of the critical points is that the right choice must be made for the material combination, and it has been concluded that cheap production is possible with AM by cost study. Frog and spiny shark skeletons were scanned by Thomas et al., and production was performed with stereolithography technique, one of the AM methods. The quality of the printed models was researched and evaluated, and it was concluded that the print quality produced the scanned data with high accuracy, and accordingly, scanning quality was one of the most critical factors. Chen et al. Selected patients with hand fractures, one of the most common cases, and randomly divided them into groups. For the treatment of patients, patient-specific fractures models were produced with AM. The results showed that the models had benefits in operative time, blood loss, and recovery time. In the study by Leary et al., tumors and anatomical models were printed for surgical planning with AM technology. The tumor and spine models are printed in different colors to make the models more transparent. Thanks to the printed models, surgery planning was done by examining the spread of the tumor before surgery and taking the necessary precautions. Different anatomical models with complex shapes and difficult to produce with conventional techniques have been published to observe and evaluate the competence of AM. Paramasivam et al. Used FDM, one of the AM methods, and PLA as the material in creating models. The skull, spine, hip bone, femur, knee joint, and foot models, which have relatively complex structures and are used as training materials and guides in surgical planning, have been produced. As a result, these models, which need to show details well to be successful as educational material and surgical planning assistance, have been successfully produced by FDM and have successfully shown details. Conclusion: AM technology is among the breakthrough production methods in recent years. Ongoing research in this area increases the preference for this method by bringing new advantages over its advantages, such as producing existing complex geometry structures, adapting to different situations, material diversity, and accessibility. AM is one of the industries where AM is widely used in medicine. And in this field, AM offers some advantages over traditional methods with different applications. As a result of the literature review, it was seen that the production of anatomical models among different areas of use could also be done with this method. In the studies conducted, it has been seen that anatomical models are beneficial in the education of medical and veterinary students, in preoperative planning, in making the communication between doctor and patient more effective, and understanding the current situation patients better during and before surgery by helping to reduce duration of the surgery and blood loss. Besides, the examples have shown that AM can produce low-cost, affordable, harmless, and detailed models. With ongoing studies, AM technology is expected to be used in various applications areas in the future thanks to new developments, and it is considered a promising production method. Here are my references. Thank you for listening.